Okay, so this is how I did problem number 4 on the Unit 8 homework set. So the first part of the problem is requires the use of the right-hand rule. It asks us which direction the current goes through. So because we know that the B field is into the board, and we also know that the whole rectangle is moving this way, we can just kind of use our right-hand rule to with our fingers pointing down and our thumb pointing that way to know that the current will go through this way, this way, this way, because A would be where it was affected. So push up, and as a result, the conga line of charged particles will flow clockwise, which is answered here. So B asks us about terminal velocity. So it took me a while to figure this out. So here are the equations I used. EMF is the negative B field times the length of the wire exposed times the velocity, and then the current is the EMF divided by the resistance. So I substituted EMF in this current equation. So now you see that EMF is negative BLV over R, current, and then I used the force of the magnetism would be I, then the product of L cross B, the cross product. So using this, I substituted this I for that. So instead of I, it now becomes BLV over R. And once I multiplied all the values, I got this. And then forces, the only forces acting on it is mg. I drew a free body diagram. So mg, and then I isolated V, and I got this, which is what is on the book. The next one is power. Power is energy over time. After looking at my equation sheet, I also discovered that power is the dot product of force and velocity. And because we know the force is just mg, and then we know the velocity as we've solved for it in the previous part of this problem, and we know the cosine, we know the angle is 0, so cosine 0 is just 1. I multiplied both sides. I did the dot product, and I got what was on the book. So that is how you do problem number 4.